Advanced Math, Lesson 10, Equation of a Line, Rational Denominators, and Completing the Square. We're going to go ahead and skip equation of a line because that's something that we cover pretty regularly in class, and it's probably the thing that you guys need the least help on. And we're going to go straight to rational denominators and completing the square. So rational denominators, we'll have problems like this. Usually fractions with some type of radical or imaginary number, and we need to rationalize the denominator, meaning we have to turn it into a type of real number. Well, not real, but rational number. And we'll just jump straight into it. So, on this example, we have 4 plus square root 3 over 2 minus 3 root 3. We cannot have a radical in the denominator. It does not work. That makes it an irrational number. So, the way we get rid of this is if we have a polynomial, like here we have a binomial of 2 minus 3 root 3, we're going to multiply by the opposite of that, or well, not the opposite, but the conjugate, thank you, the conjugate, which is the exact same number, except we change the sign in the middle of the polynomial. So instead of 2 minus root 3, we're going to multiply by 2 plus 3 root 3. And the reason why we change the sign is so that way we can completely eliminate the radical. If they both had the same sign, when we FOILed these two numbers, we would still end up with a radical in the middle term. What this does is it eliminates the middle term. So don't forget to change the sign when you multiply. So we multiply that by the bottom, and then we also multiply it by the top. So the top will get multiplied by 2 plus 3 root 3 as well. Now on the bottom, when we FOIL this, 2 times 2 is going to give us 4. Negative 3 root 3 times 3 root 3 will give us negative 9 times 3, which would be negative 27. And I can completely ignore the middle term because I changed my sign, meaning that it will get canceled. So, I mean, here I would get negative 6 root 3. Here I would get positive 6 root 3. They're going to cancel. So my denominator is simply just 4 minus 27. Now, for my numerator, I'm going to go ahead and FOIL. 4 times 2 will give me 8. Last times the last would give me 3 times 3, which would give me a positive 9 on the end. 3 root 3 times 4 would give me plus 12 root 3. And then 3 root 3 times 2 would give me plus 2 root 3. So for the numerator, these two will combine to become 14. 8 and 9, well, yeah, we'll do that at the end. So we have 8 plus 9 plus 14 root 3 over 4 minus 27. So to continue rationalizing this, I'm just going to solve or simplify it as much as possible. So 8 plus 19 is going to give me 17 plus 14 root 3. And then 4 minus 27 is going to give me negative 23. Let's see this. There we go. And that's my final answer. That's it. I'm done at that point. This can be my final answer. Another way that you can change up the answer is if you don't like having negatives in your denominator, you could move it to the numerator, and your answer could also be negative 17 minus 14 root 3, because the negative would distribute to both of those terms in the polynomial over positive 23. So that's also an acceptable answer. You really don't have to change it. If you want to, you can, but both of these are fine. Now let's go on to the same type of problem. We need to simplify by rationalizing the denominator, but here we have imaginary numbers. It's really not fair to negative square root of 1 to call it imaginary because it is a real number, but we'll call it imaginary nonetheless. So we'll start by simplifying our i's. This will take out 2 i's and become positive 1i. This will take out 4 i's and just become 2i. So 2i plus 1i plus 2i is going to give me 2i plus 3i. So our numerator is now 2 plus 3i. And our denominator, we'll go ahead and rewrite it in rational or rational form. So we would just put the rational number first, and then put the irrational number second. Sorry, that's not a plus sign, that's a negative. Minus 2i. And so now this is what we're dealing with. Again, just like above with the radicals, to get rid of this I, or this imaginary number in the denominator, we're going to multiply by the conjugate, which is the exact same polynomial, but the sign is changed. So now when I multiply, 4 times 4 will give me 16. Negative 2i times positive 2i would give me negative 4ii. The 2 i's would make the negative 4 positive 4. So I just get plus 4. So when we multiply here, I get negative 4i, two i's become negative 1, which makes it positive 4. And then again, these two middle terms will cancel, so I don't have to worry about those. This is my new denominator right here. Now for the numerator, I multiply that by 4 plus 2i. 4 times 2 is going to give me 8. 3i plus 2i is going to give me plus 6ii. In the middle, I'm going to have plus 12i and then plus 4i. So this plus 6ii is going to become a negative 6, and then the 4i and the 12i will combine to become 16i. So I have 8 minus 6 plus 16i. 8 minus 6 is 2. So I have 2 plus 16i in my numerator over my denominator of 16 plus 4, which is just 20. From here, I can go ahead and divide by 2. I can either factor the numerator or just realize that I can divide both of them by 2. If I divide both terms in the numerator by 2, I get 1 plus 8i over 10. If I factor it, then I have 2 times 1 plus 8i over 20, which cancels to 10. Both ways get you the same answer. Feel free to use whichever one you like. And I believe that's it. No, we still have completing the square. I'll try to make this as quick as possible. We'll do one example, and it will be the hardest example. So we have to solve negative x plus 3x squared minus 5 by completing the square. So the first thing we need to do is rewrite this equation in the proper order. So, and the proper order would be descending order. So this would become 3x squared minus x. And then I'm going to go ahead and I'm going to leave the negative 5 on the other side. So remember, in complete the square, you want all the x's on the left side. You want all the whole numbers on the right side, whether whole numbers, fractions, non-variable numbers. So equals negative 5. Now you notice I left a blank here, and that's part of my complete the square. So when you complete the square, you want to leave a space here and here, because you're gonna have to add the exact same value to each side of the equation to complete the square. And the steps to complete the square are to take this coefficient of the single x term, not the x squared, the single x, the coefficient, which is negative 1. We take this coefficient of negative 1, we divide it by 2, and then we square that. So negative 1/2 squared is going to give us positive 1/4. And that is what we're adding to each side of the equation. And this number could be negative. It's okay for that number to be negative, but it typically won't be when we're squaring it. You know, actually, now that I think about it, I don't think that number can ever be negative if we're squaring rational numbers. I don't think there'd ever be a case where you'd have to square an I. So, yep. So that number is going to be positive. So we're going to add 1/4 to each side. And from here, what we've done here is we've made this polynomial a perfect square. Whereas before, if we were to move positive 5 over here, there would have been nothing that we could have done there. And oh no, I think I forgot a step, didn't I? Yes, I did. Did we restart the video or did we correct it? We're going to correct it. Okay. So the mistake I made was I jumped the gun in dealing with this coefficient of x. What I should have done was I should have eliminated this coefficient of the x squared. So the first thing we should have done is divided everything by 3. If we divide it by 3, that gives us x squared minus 1/3 x equals negative 5/3. And then we have room for our squared number. So then, again, we just take negative 1/3, we divide it by 2, which is going to become negative 1/6. So we have negative 1/6 squared, which is going to become positive 1/36. And that's what we add to each side of the equation, 1/36. So from the top, write it in descending order, divide by the coefficient of the x squared, take the coefficient of the single x, divide by 2, square it, add that value to both sides of the equation. Now from here, I can factor this into a perfect square, which is going to be x minus 1/6. So the value that this number was, after we divide this number by 2, that value is what's going to go in our parentheses. So we have minus 1/6 in each of these. And then we have to combine negative 5/3 and 1 over 36. And 3 times 12 would give me 36. 5 times 12 gives me 60. So that's going to become negative 60 over 36. Negative 60 plus 1 gives me negative 59 over 36 on the right side of the equation. So what I'm going to do now is I'm going to rewrite these two parentheses as one parenthesis squared. So it would just be x minus 1 over 6 squared equals that. And from here, I just take the square root of each side. So then that's just, the left side will just be x minus 1/6. The right side, we're going to have the square root of 59i over 6. And that's going to be a plus or minus value because we don't know if 6 is positive or negative. From here, all we have to do is add our 1/6 to each side. That will cancel, and then I get x equals 1/6 plus or minus square root of 59i over 6. And that is our final answer. All right, so I hope I didn't confuse you too much in the beginning. And again, we went over 10 minutes, so hopefully I'll stop doing that. Just to recap, write in descending order, divide by the coefficient of x squared, take the coefficient of x, divide by 2, square, add to each side, factor, find the square root, and simplify.